Okay, so we're going to start on topic 6.2. And then I'm going to break this up. You'll have probably about three videos, and it'll be, so we'll go topic 6.2.1 for this one. Okay, so the first part of it. We're going to be talking about alpha, beta, and gamma particles. 2 M's. Let's just first look at these. Just sort of identify each one. Beta, sorry, that's an A, and just sort of look at the properties of each of these. So alpha particle, we've already been introduced to it a little bit with the Geiger-Martin or Rutherford experiment and the gold foil. It helped determine that there was a nucleus of an atom, a very dense central core. Alpha particles are helium nuclei, which all three of these particles arrive from the nucleus. So they all come from the nucleus, from radioactive decay. So these all originate in the nucleus, all three of these. And so alpha, beta, and gamma particles. And alpha particle is a helium nucleus, and it has atomic mass of 4 and atomic number 2. So therefore 4 minus 2 gives us 2 protons. A beta particle, a B with a, and this is the symbol for an alpha particle. So that's the Greek symbol. And this is the symbol for a beta particle. A beta particle is just an electron with 0 mass and a -1 charge. So basically, it doesn't have 0 mass, but I mean, basically they consider it to really not have much mass. So that's, and then if you do 0 minus 1, you don't get any protons or neutrons in there at all. And so the -1 they just put right there to indicate that it's opposite of a proton. And then a gamma particle, and wait, the beta particle originates from the breakdown of a neutron in the nucleus. So a neutron yields an electron and plus a neutrino, an anti or a neutrino. We'll talk more about this, but a neutron breaks down into an electron plus a proton. Now, this does not say that a neutron is a proton and electron combined together, and then you break them apart, and that's what you get. But just think of it that way. A neutron breaks down inside the nucleus of an atom, yielding an electron and a proton. And then finally, the gamma particle is that is the symbol for it. And it is this is the funkiest one. It is a massless, chargeless particle. So it basically is a photon, and it originates also in the nucleus, as does the alpha particle and beta particle. So imagine having no mass and no charge, and this one has this has no charge, and this one right here. This one has a -1 charge, the beta particle, and then the helium helium particle has a +2 charge. So +2 charge, -1 charge. It's just in relative scale here, and I'll put a 0 here for no charge. So let's take a look at those for a second. So if I were to put a magnetic field here, and then shoot a beam of all three of these particles in this direction. So by our right-hand rule, the alpha particles would go up this way. The gamma particles would just go straight through because they have no charge. And so this is the alpha, this is the gamma, and then the negative electrons would be curved down this way, and this is the beta particles down this way. So there is a way that you can detect these coming out of a nucleus of an atom. Alpha particles. So let's just talk more about that alpha particle. So helium, and think about this. This is a pretty big particle. It's got atomic mass of 4, and as it rips through the space, so imagine this particle being ejected from the nucleus of an atom, and then it's just going off through air. And as it goes through air, it has the ability to rip electrons off of the particles it encounters. And when it does that, that means it has an ionization ability. So the ionization just means that it charges the certain particles as it rips through it, because it rips their electrons off. And there's a great table. Let me see if I can find that just a minute on page 3. It's in 3 there it is, 374. So check out the table on page 374, and you'll find that this alpha particle actually does the most ionization of the air, and it makes sense because it's the biggest, so it's going to encounter a lot, and so it'll rip off more of the particles it encounters, rip off more of the electrons, causing them to become ions. Now, if this has the ability to rip off electrons, then what about the other two? Knock them loose, knock the electrons loose, and create ions. Then what about the other two? They also have the ability to do that too, and excuse me. The beta particle would be next in order of ionization, and then finally the gamma particle would be the least. So it's sort of funny because the penetration power, that means how far can they penetrate into a substance, is the exact opposite. So ionization, from greatest to least, is the alpha, then the beta, then the gamma. And so decreasing ionization this way. So that's all one topic right there. So decreasing ionization as you go to the right. Now, if you ever watched the people working on radioactive material and they're wearing clothing and stuff like that, and I always used to wonder, well, why are they wearing that? I mean, isn't it a fact that radiation goes right through most stuff, and they had to build these huge bomb shelters that people were scared of, and lead lined, so that they could, in case there was a nuclear explosion. In the Cold War, that people built bomb shelters in their backyard. But anyway, long story short here, that in general you can block most radiation with just some good material. So, like a good, well-built clothing can block alpha particles. So alpha particles, remember that's the alpha symbol, can be blocked with just some good clothing. It literally has just a very, very, it can, basically the air will block it eventually. So it can be blocked quite easily. And in beta particles, you could even just get like maybe a little bit of metal, like maybe an aluminum can or something, 2 aluminum cans, the thickness of 2 aluminum cans, maybe a few millimeters of metal will block most beta particles. Remember, that's the electron. And gamma particle, this will go through many centimeters of lead. That's the atomic symbol of lead, and so it goes through quite well. And so this is where people were talking about with the nuclear bombs, for instance, back in the Cold War scare days, that they wanted to protect themselves from, because literally your house would protect you from most of the radiation, assuming it withstood the blast. Those are the three particles: the alpha, beta, and gamma, and the absorption of them. And absorption would be how well they penetrate in, so you absorb it, and the properties of them. So we'll stop with that for this video. So this is 6.2.1.